We get massive temperature swings here in Greece, I guess like most places. Pretty cold in the winter and scorching hot in the summer. Enter my new sourdough fermentation chamber. This is going to help me with my own baking, but it's going to be an integral piece of equipment for plotting the fermentation times for the new sourdough calculator I'm putting together. There'll be a link for that in the video description, and all of the equipment and the instructions will be on the website, which will also be linked down below. And in that blog, I'll give you some ideas for other chamber solutions that are cheaper and a little bit smaller. So be sure to check that out. Now, I want to avoid doing anything destructive while I'm converting this fridge. So no cutting, no drilling, no ripping, nothing destructive. Now, the full width glass shelves are going to stop that heat from circulating properly. And I don't need any shelves in the door. So I'm going to remove everything from inside of the fridge. That's going to promote really good air circulation. And to provide the heat source for the chamber, I've ordered a tubular heater from Amazon UK. Now, as I live in Greece, I needed to chop that plug off. Now, that was no bad thing because the cable was too big to pass through the door sill, but I was able to feed it down through the drainage hole, which leads out the back of the fridge. A nice, tidy, non-destructive solution. Now, I was a bit worried that the heat would travel directly up inside the fridge, creating hot spots on the bottom of the dough containers. So I installed a small USB fan that would blow over the top of the heater and circulate that warm air. And I was really lucky because my wire cooling rack fits that fridge shelves perfectly, and that allows the heat to circulate too. Now, it wasn't quite sturdy enough, so for the moment I've added a glass shelf that only covers about half the depth of the fridge, still allowing that air to circulate. A proper shelving solution is next on the project list. If you've got any ideas, please do let me know. Just remember that good air circulation is key. Now, an Inkbird temperature logger sits on the shelf and it gives me a continuous reading straight to my phone just to make sure the temperature's where it should be, and it alerts me if there was a spike or a drop-off during a session. That data can also be downloaded in a spreadsheet format if I need it. Now, I'm also adding a light that can be controlled wirelessly, and I'm going to position my GoPro camera on the shelf. That way I can monitor the dough during the fermentation periods. You'll see more about how this will work in an up and coming video. I needed a temperature controller that could switch between heating and cooling the chamber, so I purchased the Inkbird ITC 308 for this job, the brain of the chamber. It's mains powered and it's got a probe that sits inside the chamber and monitors the temperature. It's got two power outlets, one for heating and one for cooling. So let's say I want to maintain a temperature of 25 degrees Celsius. If the room temperature is lower than 25 degrees Celsius, I'm going to plug the heater and the fan into the heating output on the controller. The Inkbird will then power that heater and fan until the temperature inside the chamber reaches 25 degrees Celsius, and then it's going to switch it off. So the temperature will then naturally slowly drop until a pre-programmed heat difference is reached. Mine is set to 0.3 degrees Celsius. So when that internal temperature of the chamber drops to 24.6 degrees Celsius, that controller turns the heater and the fan back on until it reaches 25 degrees Celsius again. So the fridge is really well insulated, so it retains heat for a long time, meaning that the heater isn't continuously switching on and off. This has been the most accurate way for me to set this up. So when I need to cool the chamber down, I just set everything up in reverse. The heater and the fan are unplugged and the fridge is plugged into the cooling output of the Inkbird controller, and that's used to regulate the temperature in exactly the same way. Now, I haven't been able to test that yet as it's not that hot, but when I do, I'll let you know exactly how I dial that in. This setup has given me an extremely accurate way to control the temperature in the chamber and is going to be an invaluable tool for accurately recording the fermentation times and the temperatures for the calculator. Now, opening or closing the door will introduce some cooler or warmer air, albeit for a second or two. It causes a bit of a temperature fluctuation. I want to keep that to a minimum, especially when I'm recording data, and that's why I'm experimenting with the light and the camera setup. Now I can turn the light on with an app on my phone and then use the GoPro app to switch on the camera. And then I can monitor what's happening inside the chamber. Now I should note that you can't leave the light on as it does generate heat and then that plays around with the temperatures. Now it works, but it's not great. The GoPro isn't that responsive when connecting through the app. So I'm going to be upgrading to a new camera system very soon. And once that's done, I'll do an update. This has been great for my recent videos where I've been maintaining constant temperatures while fermenting my starter, bulk fermenting, or proving the sourdough in the baskets. It's an amazing tool for fermenting sourdough. Now, if you've got any questions about the chamber, drop me a comment or an email. Thank you very much for watching. I'll see you again very soon. Stay tuned.